The effects of the climate crisis are felt more acutely in the Arctic than anywhere else on the planet. The weather in the Arctic is not only severe, but it changes extremely quickly. More frequent data are urgently needed to improve weather forecasts for this susceptible polar region. Enter ESA's Arctic Weather Satellite, a brand new mission to show exactly how this can be achieved.
The Arctic Weather Satellite embarks a passive microwave radiometer that measures radiation from the Earth's surface and also from various different layers in the atmosphere, which will allow atmospheric temperature and humidity profiles to be derived. While this measurement technique and technologies have been well known for several decades, AWS, the Arctic Weather Satellite, will embark a new instrument with new frequencies, and it is these new frequencies and capabilities that will be demonstrated on Arctic Weather Satellite.
The Arctic Weather Satellite will measure temperature and humidity profiles from ground to up to 20 kilometers of altitude, and in over 1 second it will scan about 2000 kilometers watt. So in 1 second it will provide a large amount of data for the end users, which is not going to be possible with traditional means. These measurements that Arctic Weather Satellite provides are also the two most important measurements for weather forecasts, which are the temperature and humidity.
The real innovation in Arctic Weather Satellite instrument is the miniaturizing of the technology. We achieve to reduce the size of the instrument of 1/5. So today the size of the whole Arctic Weather Satellites is equivalent to an instrument in a traditional meteorological mission.
ESA has embraced the concept of new space to build this mission, a concept that means the development must be done fast and within a very tight budget.
New space covers a wide range of definitions, from small educational nanosats to large commercial in-orbit services. With respect to Arctic Weather Satellite, it covers a short development timescale, 3 years, rapid turnaround times and quick decision making, and also less systematic use of standard space requirements and a greater reliance on commercially available products. In addition, the Arctic Weather Satellite was developed for a fraction of the cost of a traditional large satellite.
The fact that the Arctic Weather Satellite is ready for liftoff within 3 years is a testament to what can be achieved taking the new space approach.
I consider that the Arctic Weather Satellite has already demonstrated its success in successfully developing the satellite ready for launch within a 3-year schedule and an approximately €40 million budget.
If the Arctic Weather Satellite performs well, it will pave the way to a full constellation of satellites called EPS-Sterna that ESA will build on behalf of Eumetsat.
So the Arctic Weather Satellite is the prototype for the future constellation, and the constellation will provide then these frequent revisit times of the Arctic region that is today not available by any other means.
Once in orbit, the mission will begin to shine, delivering new data for weather forecasting and complementing the geostationary Meteosat and polar orbiting METOP series of meteorological missions.
It is intended that the data from the Arctic Weather Satellite will be used operationally by the European Meteorological Services, and as such the data will contribute to both global and Arctic regional weather forecasts. However, the much larger impact will come from the subsequent constellation, which will provide much more frequent revisits over the polar regions, which will open the door for new nowcasting applications over the Arctic.
So, a lot hinges on the prototype Arctic Weather Satellite, but it is envisaged that the full constellation will ensure a future that brings faster weather forecasts for the Arctic and beyond.